Good afternoon, everybody. Today, we're going to talk about USACO 2022 January contest, Platinum level problem number 2, counting hay. So this problem is a little bit similar to the problem we had before. Frankly, it's a little bit simpler as well. Basically, what we have is we have a bunch of hays, right? That each of a stack has a height of hi, and then you want to move hays around. You can move hays around if they are different by exactly 1. Basically, you can move one to another. The question is, how many configurations you have? So for example, if we look at the first one, okay, so you have height for hays of 2, 2, 2, 3. You can move this to here, right? So you can get 2, 2, 3, 2. You can continue move this to here, 2, 3, 2, 2. And you can move this to here. You got 3, 2, 2, 2. So you got 4 configurations. The question is, how many configurations we can obtain? For problem like this, right, you can continuously increase 1. It's obviously the first choice is divided by dp. The other hint we have is n is 5,000. What does that mean? It means we can do O(n) squared. So we don't need n log n. Okay. As we said before, to do dp, you have to do 2 things. One is you need to be able to describe a unique state. Okay. Second is you need to be able to describe how to transfer from one state to another state. If you can do this, then you can do, then you solve the dp problem. How do we do this here? One interesting thing is you can move only if they differ by exactly 1. What does that mean? If you look at this example, it means you can, if only change, you're going to change state between odd and even, right? So if that is different by 1, plus minus 1, 1 difference by 1 being means 1 has to be odd, another to be even. It cannot be odd, right? That doesn't work. For example, 3 and 5 differ by 2. Cannot be even, right? 2 and 4 differ by 2. So when you switch, then you become right, even odd. Another observation you can see is because you cannot change from odd to even. Look at this case, right? You move 3 to here, you move 2 here. This 2 stays always behind those 2 2s. It's not possible to move this to front, right? Because it's different by 2. So that means, let's say if you have a bunch of odd, okay, you have a bunch of evens. Let's say odd evens and a bunch of odd. So let's say this is odd 1, 2, 3, 4, and this is even 1, 2, 3. If you only look at the odd ones, odd 1, odd 2, odd 3, odd 4. And you only look at the even ones, even 1, even 2, even 3. There's no way to move this odd, change the order of, if you just look at the odd ones, there's no way to change the order of the odd ones. For example, you cannot move this in the front because the difference is by 2, right? You can only move difference by 1, same thing. So you can only, so if you only look at the odd ones, and if you only look at the even ones, the order of this doesn't change. Right? That's because we can only move by one. That implies I actually, when I have an initial set, I actually don't care if I want to describe a state. I only need to describe, for example, I have 4 of them, 4 odd, and I have 3 even. It will describe a unique state because I cannot move the orders, right? So the order doesn't matter because I'm never going to change the order. So I only need to know how many odd I have, how many even I have, then I uniquely describe the state. So basically, I could have a dp of number of odd and the number of even that describe my state. So that is my first requirement, right? Unique state. Okay. Now let's look at my second requirement. How do I change from a state to another state? Okay. So let's say you have a bunch of those. You have, for example, 3 odd and 4 odd, 3 evens. Let's say I add another one. Okay. One approach, one combination is I don't move this thing. Okay. I don't move this thing at all. I keep this. Then obviously, whatever the previous one I have, it will be it will contribute, right? In other words, let's say I have this much odd, this much even. Okay. So it will be initially everything is 0 is dp of if this is odd, if this is odd, then it's odd minus 1 even or dp of odd even minus 1, right? So if odd, if the last one is odd or if the last one is even, right? So that's the first one. I don't move this, I stay here. The second option is I'm going to move this, right? So I'm going to move this. I'm going to move this forward. Okay. So how do I move this forward? So let's say this is odd. Okay, let's look at the first. Let's assume this one is odd. Okay, it's odd. If I want to move forward, I need to see whether I could move forward or not. As I said earlier, if I can move forward, okay, let's say if I can move forward, okay, if I can move forward, then what happened? So then this is odd, right? So this has O minus 1 odd and have the same even, right? So if I can move forward, okay, then I basically add, I switch, right? If I can move forward, okay. So I basically switch. So this if I can move forward, what happens? So this becomes even, right? And here is even minus 1. Odd is O of odd, right? So my basically dp of odd even basically plus equals dp of odd even minus 1, right? So if it's odd. If it's even, then the other way around, right? So if it's even, same thing. If it's even, if this number is even, and if I can, then dp of odd even plus equal dp of odd minus 1 even, right? So now what I left do is, how can I do this? How can I determine if I can move forward or not? Okay, so I can count. Okay, so I can try to see, as I said above, right? Odd will not jump odd, so odd just need to jump over even. So of course, in this case, right? So if you look at this case, I mean, you don't, you have a bunch of odd thingy, you have a bunch of even thingy, you have odd thingy, So this is your odd. So then you have a bunch of even thingy, you have even thingy. That's the only way you can jump forward. So I can count. I mean, I can calculate once. So for each of the number, let's say, so for example, if this is odd, right? If this number is odd, I can try to find for everything before, what is the last number? What is the last even, right? Last even that I have, if I do it, I cannot jump. That I cannot jump. Right? I just need to figure out that number. Okay. Once I figure out that number, then I can figure out. Right. So if I, for example, okay, let's make an example, right? So in the front, so let's say in the back is my odd number is 7. In the front, let's say I have 3 even numbers. I don't care about odd, as I said. So if I have 2, if I have 6, let's say if I have 8, the last number, and let's say, let's make sure I can jump. Let's say 2A6. The last number I cannot jump. 6 I can jump, right? Let's say I have another 6 here. The last number I cannot jump is this number, right? Basically is second even. Okay, so if I, I make a function of, if I have a function of f, for ith number, if it's odd, then what is the last even I cannot jump? So in this case, it's a second. Okay, so I have, in this case, I have 4 even, right? So I have 4 even inside here. If that last number I cannot jump is less than 4, that means, for everything here, I could jump. Right? So then, yeah, I can move forward. If the number, so for example, let's say there's another bunch, there's another 8 I was considering here, then I cannot, right? Because that's more than that. So this number I just need to calculate it once, right? That's, O(n) squared is double for loop, right? For every one of them, I look for everything before. I probably could use a segment tree to make it faster, but I guess O squared, because n squared is enough, so I don't care. So this I calculated once. Once I calculated that, then I do this dp, right? So okay, so then I solve it. Okay, so now let's summarize it. Let's do a kind of like a pseudocode for it. So first phase, we're going to see in it, right? See in the array. Then we need to, when we see in the array, we also need to count odd, and we need to count even, right? Then we do this f function, right? Do this f function. This function is for each I from, first one, if I index 1, I mean from 1 to then for I probably should indicate whether it's odd. Let me have an indication of 0, 1 means even or odd. Okay, basically for j in 1 to I minus 1, right? So I'm trying to see if it's a barrier, if I cannot jump, means bigger than 2, right? Bigger equal 2, then this f of I 0 or 1, that is basically mod 2, right? Mod 2 of this a is the max, right, of previous f of I of this thing, and then this j thing, right? So I calculate f(i). Then I do dp, right? And then I do dp. So basically for odd is in 1, if I index 1, okay? Context odd, count of odd. And then for even is in 1 to count even, right? Then we're going to do, first is dp of odd even is so the I start from, right, then if it's odd or if it's even, I do plus equal, right, dp of one of them have to minus 1, right? Another is the same, okay? Then I do, then I calculate if can move forward, right? Then I do that second dp, right? Okay. So that's basically it. So it is just straightforward dp. The key is, again, for every dp, key is the first one, can you identify a unique state? The second one, can you move from one state to another state? Okay. If you can identify those, then you solve the dp. Okay. This one is a little bit straightforward. So today we have a little bit more time, right? So we will take a 15 minutes break, and then we will talk about problem number 3 later. Okay, so again, homework today for this one is to obviously code this. It should be straightforward. Okay, I'll see you back in 15 minutes.